This is a cylinder head. These are my rocker arms. This is my camshaft, runs through the center. Underneath here is my valves. If I turn the cylinder head over, we have my combustion chamber. We have two valves. The larger valve is always the intake valve. The smaller valve is always the exhaust valve, because fresh air and fuel occupy more space than burnt air and fuel. So we need a larger volume to get the air into the cylinder. We also have the spark plug that ignites the fuel mixture. This is my cylinder head deck. This is what seals on the engine block. And we have passageways called galleries for the coolant to flow through to remove the heat from the valves and the combustion chamber. We also have passageways for oil that will lubricate the camshaft and the valves. The camshaft receives pressurized oil, and the rest of the cylinder head receives splash oil or indirect oil left over from lubricating the camshaft. If we rotate this, we have our ports, and these ports there's two types. There's an intake and an exhaust. They connect to the valve. So we can see this is the intake valve. So this is going to be the intake port. If we turn the head over, we now will see the exhaust port. Another way to be able to tell is the exhaust port's always going to be dirty, because it's where the exhaust flows with the burnt gases and the soot from combustion. And typically the intake ports will be cleaner because they only have fresh air or fresh air and fuel flowing through them. So the first step to disassemble the cylinder head is to remove the camshaft. We want to remove it in the opposite way we would tighten it. When we tighten one, we always go from the center out. When we loosen them, we always go from the outside to the center. This prevents the camshaft from bowing and possibly cracking. So at this point, we are going to go ahead and remove the camshaft. Once we get them loose, then we can pull them the rest of the way out. And then we can remove what we call the rocker arm assembly. So this is my rocker arm assembly. We have my rocker arms, which are these parts here. And we also have our lifters or tappets, which are inside, in this case, of the rocker arm. These are hydraulic lifters, so you can see how there's some push to them. And this absorbs clearance between the valve and the rocker arm. When the engine is cold, the parts are smaller, so there's a larger gap. So this little piston would extend to keep the clearance at zero, so we don't get excessive wear or we don't get any noise. As the parts heat up, they expand, and then that would force this little piston inside a little bit more, maintaining the same clearance. And this is going to keep the valve from hanging open. If valve clearance is too large, then the valve will open later than it should, and it will close sooner than it should. If valve clearance is too large, then when the engine's at operating temperature, the valve will not close, and then that could lead to poor running, or in a worst case scenario, a burnt valve. So the hydraulic lifter makes up that clearance. Some vehicles use a mechanical adjustment. You make the adjustment when the engine is cold, and then when it heats up, that clearance would go back to zero. This is called a roller rocker because on one end of the rocker arm, instead of being a flat device that rubs on the cam, it rubs on a little wheel. This reduces friction and reduces the heat inside of the cylinder or on the cylinder head. There's going to be one rocker arm for each valve, and this end of the rocker arm runs off of the camshaft. So we're going to go ahead and set this out of the way. And we now have our camshaft. The camshaft has lobes. Each one of these lobes operates a valve. It also has main journals where it sits in the cylinder head. That's where it receives its lubrication from, and that's the support for the camshaft. When we talk about cam lobes, we talk about the lift of the lobe, and that's how much it's going to open the valve, and that would be how tall it would be. Then we talk about the duration, and that's how long the valve would be open, and that would be the total distance from one side to the other of the cam lobe itself. So the valve would start opening here. This would be called the opening ramp. Then we have the nose of the valve, and then we would have the closing ramp. So from this point to this point, the valve is open. At the very nose of it, that would be the widest the valve would be open. So this is lift, and then from this point to this point would be duration. And that just determines how much air we can get into the engine or how much exhaust we can get out. On the end of the camshaft, it may have a gear. That gear can be used to run a distributor or other devices on the camshaft itself. Next, we have our valve assemblies. They consist of a valve spring, a retainer, and 2 valve keepers that hold the valve in place. These are my camshaft bearing saddles. All right, so the next thing we're going to do is we're going to remove one of these valves. In order to do so, we need a tool. This is a valve spring tool. They come in different styles. This is a mechanical one. They have them run pneumatically or by air. They also have some that are smaller that you can actually take the valve spring off while the head is on the car in case you need to change the seals that are located underneath here. We're going to flip the cylinder head up on its side. And I am going to put the base of the tool right here on the valve, and I'm going to put the cup of the tool over the valve spring. All right, so I'm going to take the tool like this. I'm going to place the cup over the end of the valve spring, and I'm going to place the end of it on the valve, and then I'm going to make my adjustment. So when I'm looking at this, I want the end of it right up against the valve so it covers as much of the valve as possible in the center. And then we can see this arm here. And when I do my adjustment, I want to make sure that this arm is at 90 degrees or straight across here. So 90 degrees to the tool this way or straight along the front edge of the tool. And that tells me my adjustment is correct. You can see how this is a little bit downward. So I'm going to turn the screw on the end and make that so it is square like so. Then I'm going to push down on it. And when I push down on it, it compresses the spring, and now I can get to my 2 keepers. So there's one of my keepers, and sometimes a little magnet will make your life easier because they are kind of small. And then when I release the tool, then the valve spring would come off. So here I have my valve spring and my retainer. Once I have the valve spring off, I can then push the valve out of the cylinder head, and now I have one of my intake valves out. So we're going to do the same thing on the exhaust valve. Set the cylinder head up, place the cup over the spring, put the valve or the end of it against the valve, make sure your adjustment is correct, compress, Now I can remove my retainers. If the adjustment isn't correct, you're either going to over compress the valve spring, or you're not going to push it down far enough. And if you don't push it down far enough, you'll never get the keepers out. Be careful when you release it, because when you release it, it is under spring tension. So if you do it rapidly, it can cause the spring to fly off of the head. So we're going to go ahead and release that guy. And now I have my second valve spring and my second retainer. And I can just push the valve back out. So now I have one intake valve and one exhaust valve out. Underneath the valve assembly, we have what we call the valve spring seat. And the valve spring seat may just be metal, or it may have a shim that goes underneath it. This shim can be used to do two things. One, it can be used to change spring pressure. And then on an aluminum head, being that the spring is made of steel, that steel will cut into the material of the head. So this protects it so it doesn't wear a groove into the head of the cylinder head. All right. Above that, we have what is called the valve guide seal, and that's this portion right here. And this prevents oil that's in the cylinder head from being sucked into the engine on the intake stroke. So typically the intake seal will be a little bit beefier than the exhaust seal, because this is where the oil gets sucked in while the piston's moving downward, drawing in air. If that oil gets into the combustion chamber, then that will cause it to burn, and then you'll get a bluish white smoke out of the tailpipe. And then of course you're going to be running low on oil, which isn't good for the engine. Anyways, all right. Once we have them out, there's a few different measurements that we have to make. The valve itself is supported by what is called a valve guide, and the valve guide are these holes down inside of here. If I were to take the valve and place it in there, we want to make sure that the valve is solid. You can see how there's some movement in the valve. If that is too much, then the valve may not shut completely flat because it's crooked, or it can cause it to leak more oil during the intake stroke. So we check this one here. All right, you can see that one has a little bit less play, and this one has a little bit more. The reason the exhaust may have a little bit more is because that's where all the heat of the engine is. This exhaust valve gets a lot hotter than an intake valve, and that heat can cause excessive wear in the guide. So to measure that, we need a couple tools. The first tool we need is called ball gauges. They're called a ball gauge because the end of the gauge is the shape of the ball. We need to find one that is close to the diameter of the valve stem. So if we look at it, we can see this one's probably going to be too big, and this is probably going to be like Goldilocks' porridge, just right. The tool has on the end of it, it has a knob, and that knob opens up the ball, making it wider. If I go in the loosened direction, it then closes the ball, making it smaller. So we're going to take the gauge and set it down in the valve guide, and then we're going to turn it till it gets a little bit snug. I still want to be able to move the tool in and out, but the tool should support itself in the upright position. Then I know I have it the correct tightness. If I cannot move it in or out at all, then it is too tight. And then if it flops over when I release it, then it would be too loose. All right, so we're going to make two measurements, one at the very end of it, and then one down at the beginning of it. Once you've taken the measurement, you're then going to need a micrometer. This is a micrometer. It does precision measuring. This one does to 10,000ths of an inch, which is 4 places after the decimal. So you got tens, hundreds, thousandths, and 10,000ths. That's about 10 times thinner than a human hair, and maybe even a little bit more than that. Once we've made our measurement and our adjustment, we're going to go ahead and remove the gauge. The gauge has a split in it, so we want to make sure that when we measure on the opposite sides of the split. So you want the split running down the center, and then we're going to place the tool on the outside edges. And the tool would go like this, and then we will make our adjustment in order to read it. Now I will cover micrometers later, so you'll understand how to use the tool itself. All right. Once we get our measurement, we want to make sure that the part will slide. Even if it's going to take some pressure, but it should be able to slide back and forth, but it shouldn't just fall out. All right, so that way you know you have the correct measurement, and then you're going to make your reading on the micrometer, and then we're going to write that down, and then we're going to repeat that step about 2/3 to 3/4 of the way through the valve guide. So we're going to go down into the valve guide again, and then we're going to make the measurement again, and then we are going to write down that number as well. If both numbers are the same, that tells me that the valve guide is straight. If one number is larger than the other, that tells me my valve guide is tapered, and we'll have to repair it. We can repair the valve guide in one of two ways. We can ream it out and install a new one, or we can do a thing called knurling, which cuts a cross-hatching bumps into the guide, which raises the surface, which actually makes them smaller. Next, we need to know what is the clearance between the valve guide and the valve stem. So we are going to use the micrometer to do that. And we would do the same thing. We would take and measure. If you can see where the wear is. There's wear here and there's wear up here. So we're going to measure here and we're going to measure here. Now, anytime we measure a circle, we have to make two measurements on X and Y to determine, number one, is it a circle, and to get the correct measurement. So we're going to make a measurement here, and then we would write that number down, and then we're going to go 90 degrees, and we would make another measurement there. If those measurements are the same, then the valve is a true circle. If they are not, then the valve has been worn into an oval. And then we're going to do the same thing up here at the top. We'll make one measurement, and then we'll go 90 degrees and make another measurement. So basically we're testing, is this valve round? Is it the same dimension through the entire stem? Or is it tapered? Does it have more wear on one area than the other? If we look at the valve, we can see these grooves right here. These grooves are for the keepers, and this is a single groove, so the valve keeper should have one groove as well, and you can see how it fits into the valve like so. All right, the wide part faces up, the narrow part will face down when we put the retainer on it. So we'll go ahead and we're going to slide a retainer over the valve, and we will put one keeper on this side. Whoops, don't lose those little guys. And then when the retainer slides up on it, the retainer grabs it and locks them into place. All right, like so. If you don't put them in correctly, when the engine is operating, the keeper or the retainer will come loose and the keepers will come out, and then the valve will fall into the cylinder, and that will destroy the engine. So it's really important that, number one, the keepers are in good shape, that groove is not damaged at all, and the valve itself is in good shape where you have the retainer grooves. Some engines use 2 grooves, some engines use 3 grooves. It all depends how much pressure is on the valve. Of course, the more grooves we would have, the better contact we have with the retainer and the keeper, and that's going to keep it from sliding off. All right, so those are our little keepers, and that's our valve. The valve seats right here on this edge, on the intake side, it should be a very thin seat, and on the exhaust side, the seat should be wider. In that way, the heat is able to be dissipated from the exhaust valve to the cylinder head more rapidly. The intake valve stays relatively cool. It has cold air and fuel running over it, and that cools the valve, where the exhaust gas valve is hanging in the cylinder, and the temperature of the gas can be in excess of 4,000 degrees, and that turns this really hot. In order to cool it, we need a larger seat. So this is my valve seat. This is my valve face. This whole thing here is called the valve head. This would be the valve stem. And then this is the valve tip. The valve seat on the valve matches with the valve seat in the cylinder head. If it is an aluminum head, like in this case, then the valve seat is either going to be staked in or pressed in. If they get excessive wear or they crack or become damaged, we can remove them and install a new valve seat. If it's a cast iron head, the seat is typically part of the head. So if it fails, we then have to cut it out and then reinstall a replacement seat. All right, so now we are going to test the valve spring. Let me move this head out of the way. And we use what is called a valve spring tester. And we are going to test the valve spring for a couple different things. We test it for freestanding height. How tall is the valve with no pressure on it? We then test it for the compression height. So we're going to put a specific amount of pressure on the valve, and then we're going to measure how tall the valve is under that pressure. We're going to check it for squareness to make sure that it is square. If the valve tilts or the spring tilts while it's in operation, that can cause the valve to bend or break, and that would cause catastrophic engine failure. So we use this tool called the valve spring tester. It has a gauge on it, and it has a ruler on it, and this ruler was where we'll make our measurements. So the first thing we would do is set it on there like so, and we're just going to bring this down till it touches it. We would then read off of this needle on this ruler what is the freestanding height, and then we would compare that to the specifications. The specifications will also tell us how much pressure this spring should be under. So if it said that it was 60 pounds of pressure and it should be 1 5/8 of an inch tall, we would then push down on this till the needle reached 60 pounds. And then we would read the measurement off to the side and determine whether or not it is at its correct height. If the spring becomes weak, in order to reach that 60 pounds, we would have to go farther, which would make the valve spring shorter. So by checking the measurement at a specific pounds, we now can tell if the spring has good tension or good spring to it, and whether or not it would be able to handle being put back into the engine of the car. All right. The next thing that we would check on a cylinder head is whether or not the deck of the cylinder head is flat. So I have a different cylinder head here. This one is a cast iron cylinder head. When we take it off the car, there is a head gasket that covers this, that is a seal between the head and the block, and in order for it to seal, this surface must be flat. If it's not, it will cause either oil leaks, compression leaks, or water leaks. So we use a tool called a straight edge, and this is a straight edge. The straight edge has a protective sleeve on it because this edge is perfectly flat underneath here. So when you're using this tool, make sure as soon as you're done, you replace this sleeve to protect that edge. If that edge gets nicked or damaged, then the tool is no good, and you basically just have a ruler with no measuring markings on it. So we're going to go ahead and pull the sleeve off. You can see that the edge of it is nice and shiny because it is perfectly flat. We're going to make several measurements on this, and we're going to be looking for a variation. So we'll need another tool, and the other tool that we will need is called a feeler gauge. This is a feeler gauge. It kind of looks like the old Asian fans, but it doesn't do a very good job of cooling you. All right. These parts are called leaves, like on a tree, and they're different thicknesses. And on the leaf itself, it will give us the specification of how thick that particular leaf is. So we're going to look up the specifications, and the specifications will tell us what is the maximum amount of variation we can have across the cylinder head. And we're going to use this tool in conjunction with the straight edge to determine if there's an issue or not. So we're going to make several measurements. First, we're going to take the straight edge and we're going to place it about 3/4 of an inch to an inch from the edge. And then I'm going to take my feeler gauge and I'm going to attempt to slide it underneath the straight edge. If it does not fit, then I know that is flat. If, of course, it goes through, then that would indicate that that is a low spot and the head would need to be resurfaced. So I'm going to go ahead and do it here. Then I'm going to bring it up halfway through the combustion surface, and I'm going to do it again. Then I'm going to bring it up to about an inch, 3/4 of an inch to an inch from the edge of the head surface. We don't have to go all the way out here to the ports. We're only concerned about the area around the cylinders. And I'm going to go ahead and do that again. And so far we're good. Then I'm going to make 2 more measurements. I'm going to go at an angle across the cylinder head this way and make my measurements. Oh, you can see that one went in there a little bit. All right. And you can see this one goes in also. Whoops. And we're going to go this way and do the same thing. If the feeler gauge does not go under the straight edge at any time, then that head is considered flat. We can just clean it and then reinstall it. It is a good idea to resurface them no matter what, because it gives a nice surface for the gasket to bite onto to create a good seal. However, if you're dealing with a cast iron head, you can just put them back on once they've been cleaned after you've done all the repair work that you need to do. But aluminum heads, it's a better idea to resurface them. Another method of doing this is using a flashlight. If we use a flashlight, we're looking for light going underneath the straight edge. So if I put my straight edge like this and I shine the light underneath it, if any light bleeds through on the other side, then that would indicate that you had a distortion or a warp. So if I lift up the straight edge, you can see the light bleeding through, and that's what it would look like if the head was not flat. All right, so that's 2 ways of measuring the flatness of the cylinder head. Once we have measured the cylinder head, we've measured the valve guides, we have checked the deck for flatness and squareness. We've cleaned it. We're now ready to reinstall the valves. When we change the valve guide seals, they will just pop off. If you use like a panel popper to pop them off, they'll pop right off. And then we use a special tool to reinstall them. Always change your valve guide seals. Otherwise you may end up with a leak later on. To install everything back together, we're going to go ahead and do the intake valve side first. So we're going to take our intake valve and we're going to take some white grease, and we're not going to use a whole ton of it. A little bit goes a long way. And we're going to place some grease on the valve stem itself. All right. This will allow it to slide in. It also will provide lubrication during initial startup after we put the engine together. If we don't lube these parts, they will be dry, and then they could cause excessive wear in the first few hundred miles of using that vehicle. Make sure you put the right valve in the right spot so the big valve goes in the bigger hole. And we're just going to go ahead and slide it in till it bottoms out. At that point, we're now ready to install the valve spring. So make sure that you have your washer, if it came with one, on there. If you don't put this on there, the valve will either be not the correct height or tension, or it can cut into the cylinder head. So we want to make sure that we place this over the top of that. Then we're going to place our valve. I'm going to hold my retainer. I am going to take my valve spring compressor. I am going to place the retainer over the valve spring and place the tool on it like so. Then I am going to bring it back down over the head of the valve, and then I'm going to compress it, and it's going to lock in place like so. Now I can install my keepers. These keepers will try to run away from you. So grease not only makes a great lubricant, it also makes a pretty good glue. So I'm going to put a little bit of grease on the inside of the keeper and then set it on the valve like so. If I don't use grease, as soon as I take my fingers away, that thing's going to fall. Then I'm going to be chasing them. And a lot of times you can't buy one keeper, you have to buy a set of them, and now you have a whole bunch of extras. So go ahead and place the other one on like so. Then I am going to gently hold them in place while I release the handle of the tool. And now I've installed the valve back in. All right, so we're going to go ahead and do this again. I'm going to bring the zoom out a little bit so you can see the whole process. All right, we're going to turn it over, and we are going to do the same thing on the other side. So I'm going to take my valve. I'm going to put a little bit of white grease on it. I am going to slide it in. I am going to put my base washer on. I am then going to set my valve spring over the top of it. I am going to grab my tool, place the retainer over the valve spring, place the cup of the tool over the retainer, place the other end of the tool on the center of the valve, center it with your hand, and then compress. Make sure you don't put your fingers in this area, that would hurt. And then it'll lock into place. I then will put a little bit of grease on the retainer and place one retainer on there, and then I'm going to put a little bit of grease on the other one and place it on there. Make sure that you put the large end of the keeper facing up. All right, otherwise, well, whoops, you'll have to chase that guy like I have to right now. She's down inside there. Sometimes if you drop them down in there, the only way to get them out is to bring the valve up a little bit and then push it back down. And you can see how it brought the keeper back to the top. And then I'll put the other side in. Hold them with your finger and release the tool. All right. Now we've reinstalled the valve springs. We're going to double check them to make sure that they are installed correctly. They should be flat and even with each other. If they are not, then, well, compress it and redo it because you did not get it correct. At this point, we're now ready to install the camshaft. Just like all parts, when we install them, we want to make sure that we have enough lube to provide lubrication until the oiling system takes over. So we're going to go ahead and put some lube into the valleys. The best lube that I like is called Lubricate 109, and that is an engine assembly lube. Make sure that you put the camshaft in the correct way. Do not attempt to put it in backwards. If you do, well, it's not going to work very well, and then you're going to have some serious issues when you try to assemble the rest of the engine. So always make sure that you've put it back in the correct way. And then we are going to lube the rocker shaft assembly. Now, when you're doing this, when you turn this upside down, whoops, there is a chance that things will fall out like that. That was a bolt. Also, there we want to make sure that we lubricate the lifters. All right. So in order to lubricate the lifters, we will need to use some white grease. All right, so we're just gonna, and it'll keep them from falling out as well. So just put a little bit of white grease around the edge. The hole goes down into the rocker arm. Don't leave the hole facing out. It won't work very well. And then we're gonna go ahead and push that guy down in there. And then we would do the same thing to all of them. Then we're going to lubricate the inside of the journal. And then we will take and flip this thing over and place it on the cylinder head. If by chance one of the rocker arms pops off, then just go ahead and flip it back over, and then you would be able to reinstall it. Once we have the rocker arm assembly over the top, double check your work, make sure all the rocker lifters are installed, and then we're going to go ahead and start our bolts. We don't want to tighten the bolts down. There is spring pressure because some of the valves are open and some of the valves are in the closed position, so that can cause the cylinder head to distort, and if the the camshaft to distort. And if the camshaft distorts, it can actually break the camshaft in half. So we want to tighten them gradually so we don't force or bend the camshaft. So you just want to go ahead and run them down till they barely touch. Don't put any pressure on them. So we're going to start with the center, and we're just going to go till it touches. And I'm going to go till that one touches, and that one, and that one, and then I'm just slowly going to work my way around. You'll notice that I'm not just running it all the way down. If I do, there's a good chance I could break the camshaft. All right, then I'm going to go back to the center and just run it down till it barely touches. You can hear the gun start to work, and that's an indication that you're touching or putting pressure on it. Once I get it all the way down, I'm now ready to torque it. So I am going to need a torque wrench. The specification for the bolts will be found where you find all the other specifications for tightening any of the engine components. Make sure you don't exceed that pressure. There's two types of bolts. There are regular bolts and there are torque to yield bolts. So if it is a two-step process that includes an angle, so 10 pounds plus 90 degrees, then that would be a torque to yield bolt. If it has 2 steps or 3 steps that just include foot-pounds, then that would be a standard bolt and you would not need a torque angle indicator. So we're going to go ahead and do the first step of it. So we're going to go ahead and set the torque, and you do it in steps so it prevents the camshaft from distorting. This is a digital one, so it's going to beep and make all kinds of noise when we do it. They also make click style ones, and the click style one would just make a clicking noise. Now this one has lights on it, so when you get to the green, you know you've gone the correct amount. If it goes red, then that indicates that you have over tightened it. So you have to be kind of careful. The nice thing about a digital one is even if it does go red, it'll tell me exactly how much I over tightened it. And if I just happen to over tighten it like 0.01 of a pound, then I know that I'm not gonna create any issues. Whereas the click style, there's no way for you to know how far you have over tightened it. All right, so once we go through and do it the first step, then we would go ahead and reset the torque wrench to the second step. So we're gonna go ahead and do that. And once again, you'll get these specs out of the manual. And then we'll go ahead and do the second step. And the book will usually provide the pattern for you to use. It's called a torque sequence, and it is pretty critical that you follow that. Don't just randomly tighten them. You could cause severe damage to the cylinder head. And if you damage the threads, typically you end up either having to do a helical if you're lucky, or you end up having to replace the casting, and then that would be bad because those are kind of expensive. All right, now we have the head torqued down, or the camshaft torqued down. We have reinstalled the lifters. We have reinstalled the rocker arms. We've reinstalled the valves. We've checked valve springs. We have checked the valve stems for thickness and variation. And we learned how to check the flatness of the deck. So that pretty much covers all the steps to rebuilding a cylinder head other than the machine shop work.